Hi, my name is Mohammed Afani, and today I'm going to demonstrate to you why Carnot heat engines are the most efficient type of heat engines. But first, let us start with what a heat engine is actually. Now, it can be demonstrated through the sketch where you have heat coming in, and this heat produces work and thermal energy due to the temperature difference. This can be demonstrated in this equation right here. Now, our goal for a heat engine is to maximize this work right here. A way of doing that is to eliminate this branch due to the temperature difference. This leads us to the conclusion that we need to use an isothermal process. An isothermal process is a process where the temperature is held constant. But the problem in this is that this is just one process. If we want to operate as a heat engine operates in a cyclic manner, meaning that we have to find a way to return to the original starting point. For this reason, it can be seen that we need to use another isothermal process to go back to where we started. This can be demonstrated on this PV diagram right here. These lines right here are constant temperature lines. This is the hot temperature and this is the cold temperature. Now the first process is an isothermal expansion, and the second process is an isothermal compression. But as you can see, we need to find a way to connect between these two processes. An ideal way of doing that is a process that is called an adiabatic process. An adiabatic process does not exchange heat within the surroundings, meaning it's very efficient and it contains all of the heat energy inside it. An adiabatic process is demonstrated through these curves on the PV diagram. And as you can see now, we have this cycle. But let's go back to our main goal, which is to find out how much work does the cycle give us. One way of doing that is to do it graphically. This area contained within the cycle demonstrates the work done by the cycle. Now, if we want to compare it with other processes would look like that on the PV diagram, meaning that all this area right here is lost. But you can now come and tell me, what if I make the area this box right here? Wouldn't that contain more area, hence it's more work? Well, this is a bit misleading, because as you can see, now you are operating between two different temperature lines. So what we can do is that I can draw another reversible process like that, and I would be able to cover out more area. So this leads us to the conclusion that the most efficient process is a process that contains two isothermal processes and two adiabatic processes, which is exactly what a Carnot engine is. Hence, a Carnot heat engine is the most efficient type of heat engine.